Hey, I am Brian at So Much Science, and today we're going to be doing a tutorial on how to control NeoPixel LEDs from an Arduino. This will be for total beginners, so if you have no knowledge but you have the right equipment, that's great. We will take you right from the very beginning all the way through being able to control the LEDs to do almost anything you want. What we're going to cover is how to get the right software, the Arduino IDE, to send the code to the Arduino board and do what you want. We'll also talk about how to download the NeoPixel library within the Arduino app, within the Arduino IDE. Then we will talk about which Arduino to get, which cable it's going to need, and how to hook up the LEDs for you to start doing your thing. There will be a lot of things that we skip over, that would contribute to a greater understanding of Arduino and LED lighting and all of that, but we want to get you started. If you haven't done it before and you want to get going, this is a great place to start. Open up any browser and then in the address bar, enter arduino.cc, and when you get to the website, you'll see across the top there is a menu. You can go to software and then downloads. Once it loads, scroll down a little bit, down to where it says download the Arduino IDE. I'm running Mac right now, so I will click Mac OS. And this is open source software, so you do not need to pay for it, but if you are able to make a contribution, that's great. I'm going to click just download. And through the movie magic of the internet, of YouTube, I will cancel that, and it's already in my downloads folder from earlier. Here's a zip file with the software that I'm going to need. I'm going to double click that. It will unzip in the downloads folder. All right, so now we have the Arduino application in the downloads folder, and then all you have to do is click and drag it over to the applications folder, and then you would let go there. I'm not going to do that because I already have Arduino installed on my computer and I don't want to lose any of the settings that I have put in there. So I won't do it, but it's a pretty straightforward process. You should be able to handle it great. And then once it's installed, there are many ways you can open it. I just like to open up Spotlight, hitting Command Space, and then start typing in Arduino, right arrow, open up Arduino. Once Arduino opens up, this looks pretty busy. It's showing the software I was working on earlier. Don't worry about that right now. There is a lot to cover there, but we're not going to do it at this moment. The next thing to do once you have the Arduino IDE up is go to Tools, click Manage Libraries, and this is where we're going to download the NeoPixel library. The way I like to describe it is before the internet, if you wanted to know something, well, even now, you can still do this. You can go to the library. You may know a lot of things. You already know how to eat. You already know how to breathe. But what if you want to do a science experiment or speak another language? You go to the library and you can learn it there. Well, in computer programming, we have libraries also. And when we use them or when we import them, then we can use all the abilities of that library basically. And so we're going to use the Adafruit NeoPixel library. Getting a little bit slow. Then I'm going to get these search results. It's not actually the first or second result on my screen, but here on the third one you can see Adafruit NeoPixel by Adafruit. It's already installed for me, so the install button is grayed out, but you'll just get the most recent version. Click install, and if you do want to confirm it, you can go to up here to type installed. Oh, what's going on here? Type. What's going on? Type installed, and we can see Adafruit NeoPixel there. That's great. Okay, that's step one. You got the Arduino IDE installed. You have the NeoPixel library installed. We're good. But the hardware is another big piece to getting this project to work. So first thing we'll cover is the Arduino board. I strongly recommend getting the Arduino Uno R3. It is the standard board. It works for almost any project you can imagine at this point, especially if you're a beginner. And so I would really recommend going for that one. You'll also need a cable to go with it. They typically don't come with it unless you buy some kit. And so you can buy a USB-A to USB-B cable. And the USB-A side is the standard kind of rectangular USB that you're familiar with. And the USB-B is that more, it's kind of like a square shape. And you may recognize it from being like a printer cable. It's often used to control printers. So you may have a spare one already at home, or maybe there's one you can borrow. If not, otherwise, you can just buy one. What I'm going to be using today is the SparkFun RedBoard. Because Arduino is open source, there are a lot of other versions out there, even if they operate exactly the same or almost exactly the same, but are made by somebody else. There are many other options available. So this is the SparkFun RedBoard. That's what I'm going to be using today because I already had it on hand and I'm used to using it. I find that sometimes uploading code to it is a little bit trickier. Doesn't bother me too much, but if you really are a beginner, I would recommend just getting the Arduino Uno R3. Either way, if you do end up with a SparkFun RedBoard or any Arduino compatible board, just make sure that your USB cable fits the one you got. The SparkFun RedBoard uses a mini B connection on the board, and this is what the USB-A to mini B connection looks like. This is also a cable you may have around at home already, so maybe if you have this as a spare and not the other one as a spare, maybe buy the RedBoard and then it will already fit what you have. The other thing you need, obviously, are the LEDs, and so this is what it'll look like. An Arduino without an external power supply, or I should say, LEDs being operated by an Arduino without an external power supply, you can only get up to about 8 LEDs. If it was 8 LEDs doing white, like emitting white, which means all red, all green, all blue, like full on, they draw as much current as the Arduino is able to supply. So if you go any bigger than this, you need to get an external power supply, but we'll cover that another time. So I have 8 here so that I can power it with the Arduino. And I've connected a power, a ground, and a signal wire. The power is red, the signal is yellow, and then ground is black, and you'll connect it to the corresponding pins on the Arduino. We won't cover soldering today. There are other videos online for that, or we can do another one in the future. So we'll leave that to the viewer. When you look for this, you'll want to search for LEDs and NeoPixel when you order it. You'll want to make sure that your LED strip is addressable. And the easiest way to do that is just look for the code WS2818, and that's the common chip that's used on these LEDs, on the individual LEDs, to be controlled by the NeoPixel library and the Arduino. We have all of the preparation done now, and at this point, it's time to start looking at our code so we can start making our creation. This is some code that I wrote before starting this video, and I'm just gonna go through it, starting at the top, explaining some of the main points that you need to keep in mind as you start experimenting with it, but I won't be explaining all of it because part of it's just to get you started, and then you can think about what you want to do next and then learn how to do that. So right here at the top, you can see these 2 slashes, and that text is grayed out. Those are comments. So those are places for you to write notes to yourself or to someone else that might be using the code, or for other people to send notes to you. It is saved in the file, but the computer doesn't try to interpret it. It just knows to leave that alone because it's for people to read. And then go down a few lines, you can see the hash or the pound include, and then this Adafruit NeoPixel text. And that's to include the library, the NeoPixel library, to give us all of those expanded capabilities that we talked about earlier. Then a few more lines down, we're using some variables here. So variables in computer programming are a bit different than the variables we use in like algebra and geometry, because in programming, a variable, it really is just a place to store information. It's we give it a name, and then we can refer to it in the future by that name, and it will hold some kind of information in there. What we're doing right here is we have a variable called LED pin, and we've assigned the value 6 to it. And when we do programming in Arduino, we also have to tell the computer what kind of information is going to be in there. So in this case, we have int, that's an integer. And we really want to use integers when we're doing anything where it's counted or when there's discrete steps. So for example, on our Arduino board, we have pins, and there's pin 0, 1, 2, 3, 4, 5 through 13, and some others. There is no pin 3.5 or 7.4. They're only integer values that are valid for addressing those pins. So we like to use integers there, or if we're counting something. Sometimes it makes sense to count in our program. If it's just going 0, 1, 2, 3, 4 like that, we'll use integers there. So we have a variable called LED pin. It has the number 6 there because we're going to be using the number 6 pin on our board to send data to the strip of LEDs. And then we have another variable below that, NeoPixels. So we need to tell the computer how many pixels we're going to have because it'll make that much space for information, for color information for us to send to the LEDs. And these can be named anything. We just picked something that would be descriptive and helpful later. So when we call it LED pin and NeoPixels there, we kind of know what those mean. And then we use them later down here, NeoPixels and LED here, because this function within the NeoPixel library, it needs to know how many pixels there are and how many LEDs there are so we can do what it needs to do. This stuff down here, that it's very important, but it's also more complicated than we need to get into right now. So you can just use the default values that I have here. And this whole line is basically saying declare a new variable called pixels. It's this object, it's this class that is Adafruit NeoPixels, and there's a lot going behind the scenes here, but you can easily just copy that line for now before you understand it, and you can still use it. It's no problem. One more variable down here, we have delay val, because later we're going to put in a line in our code that makes the program slow down because it can go so fast that when we're sending information to LEDs, it's too fast for our eyes to pick up. So we put a delay in there. And then we go down to void setup. Now, again, there could be a lot to unpack here, but the most important thing for you to know is that every time that you run this code, so the first time that you upload it to the Arduino, or if you turn the power off on the Arduino and turn the power back on, it runs the void setup loop once and then never again. And sometimes you may not need to put anything in there, and that's fine, but sometimes you do need to run things once, and so you put it up there. And the format is you write void and then setup with parentheses, and then there's a curly bracket to start, and then it knows everything between that first curly bracket, the open curly bracket, and the closed curly bracket. The closed curly bracket is going to be run once in that void setup loop. Or void setup function, maybe I should say. And then we have void loop down here, and this is kind of the opposite. It runs every single time. Well, it just is. That is what's running every single time. The Arduino will turn on, run the void setup, and then run void loop forever until there's either no power or an error or you tell it to stop. So everything in here is going to happen very quickly unless you slow it down. Now, here's where we're going to start setting the colors for our LEDs. One very important thing to keep in mind here now is that in programming, again, there's always special things in programming. The numbering system, or the numbering, will say, usually starts at 0. We call it a 0 index. And we're going to be doing the same thing here. So we know we have 8 LEDs on our LED strip, but you can see these are numbered up through 7. But we started counting at 0, so it's going to work out. There's 8 lines here. There are 8 LEDs. The first LED is at position 0, and the second LED is at position 1, and so on. So you can think about it as sort of like an n-1. If you had 100 LEDs, you're going to number it 0 through 99. If n is 100, 99 is n-1. There you go. And then the magic, the colors all show up in here. So this is another part that you can kind of just take for now, and then you can dig in and understand more later. We do pixels.setPixelColor, and then the position, and then this comma separates it, and then pixels.color with a capital C. and then we have 3 numbers here. And the first one is red, the second one is green, and the last one is blue. And they can be any number from 0 to 255. There are 256 levels here, but again, it starts at 0, so it's 0 through 255. If you set 000, none of the LED elements will turn on, and that's it. If you have 255, 255, 255, they'll all turn on and you'll get a white, or at least pretty close to white. There's a little bit of an imbalance in exactly how the colors show up, but you'll recognize it as white. And then everything in between, you can mix and match and do whatever you want to do, and you can change those in every loop through your code. One thing that I didn't cover earlier is that in the void setup, there's this pixels.begin that initializes the library basically. Again, there are a lot of details behind that you don't need to worry about. Just put pixels.begin, open parentheses, close parentheses, or open and close parentheses, however you want to call it. And that will get it started. And then what's happening is that the program will sort of create 8 spots to save color information, and you can change those as many times as you want in this code in here. And then once you call pixels.show, that will then send the current set of color information out. And so in this case, there are 8 positions, and you will send 8 color values out, and they're sent out in order. So then the first LED, it actually has some circuitry inside of it where it takes the first set of color information and removes it from the packet, but it uses that information to change color, then it passes the rest on. The next LED takes the first that it gets and passes on the rest of the information, and so on. And so if you send out 8 packets of information and there's 8 LEDs, the last one will take the last packet, and then that's it. And great job. And then if we go back to the code, we have delay and delay val. So delay is a function that Arduino understands, and it will take a number inside of it for the number of milliseconds to stop or to wait to do the next thing, to move on to the next line. And we set this variable delay val earlier to be 500. So it's going to run very quickly through these lines, and then it's going to stop for half a second, and then it will get to the end, and once it hits that curly bracket, it'll go back to the top of the loop and run again. A few other things to point out is that all of these lines need to be ended or terminated with a semicolon. And it may seem like a lot of extra work, but what that allows us to do, one of the things it lets us do is if you had a really long line of code, but you wanted to keep it nicely formatted or have it go across multiple lines for a person to read it easily, you can do that. You can just separate it up like this. Now this isn't a great example. I wouldn't recommend doing that here, but you can, because the computer is basically going to put it all together until it sees a semicolon. Yeah, see, our formatting is all kind of weird here, so not a great example, but that's what it's for. And you're gonna mess it up, and you're gonna mess it up 1,000 times. You're gonna do it 1,000,000 times. I've been coding for at least 1,000 hours, and I still mess that up half the times I compile my code. So don't feel bad about it. Just be ready for it. Oh, I really made a mess here. All right, don't do what I did. The spacing is unimportant here, but it makes it a little bit easier to read. What else to tell you? That could be it. There's some extra things here I put at the bottom that I will cover another day, not in this video. It'll be a little bit too much to process, I think. That's it. You have the basics for what you're going to need to get the LEDs to change color. I'll make another video, or you can look it up, of course, yourself, on how to make the colors change while the code is running. You might want to look into if statements or for loops. That would be my recommendation on where to look next. You'll see some cool stuff. One thing that I want to be very clear on is that there are some things in the code and in the hardware that we need to make sure match up really well. So for example, the LED pin, in this example we've used 6 as the pin number. Well, we have to use pin number 6 when we hook it up to the Arduino as well. If you're looking at the Arduino, there are a lot of different pins here, and on the right side, when you have the data input here and the power on the top, on the right side we have pins 0 through 13, and then a few more labeled ones above that. When we are doing this program, we have a lot of options on what we do. I'd recommend using pins 2 through 13. Those are all going to work as we described, just like you'd expect. There's a way to use these analog pins as well, but you don't want to use pin 0 or 1, and then the pins up here can get kind of complicated. Read up on it if you're really interested. That's going to be a more intermediate topic. There are 4 parts to this LED. There's basically the high voltage side, the 5 volts. There's the low voltage side, the ground. Then there's a data in where all of that information about the colors comes in. And there's also a data out where the LED sends the remaining information on to the next one down the line. And we are able to provide that power from the Arduino as long as we're only powering about 8 LEDs. And so there's a few different ways you can hook it up, but you'll take the wire connected to 5 volts and you can connect it to the 5 volt pin on your Arduino. All right, and then the black one, or whatever's connected to ground, because the color is really just the insulation we put on the wire. On the inside, it's all copper. It all conducts electricity. It doesn't matter. You put this on ground, and there are at least 3 different grounds, and they're all the same. So plug it into any pin labeled GND on the Arduino. And then, in this case, the yellow one that I have connected to the data, but it's whatever color you pick, connect that to the pin that you select in your code. And in our case, it's going to be pin 6. Once we have the program completed, our sketch completed, see, even I did it. Once we have our sketch completed, then we're going to go to the top of our menu and you'll see a few options. This one's verify. What that does is it just checks your code to make sure there's no obvious errors in there. That's probably going to be pretty helpful for a while. You may want to do that. Like if I click verify, it compiles it, which computer speak for kind of like putting it all together. And no errors, at least not yet. And then right next to it is upload. So I can click that and it's now going to send the sketch that I created through the USB to the Arduino. Now my setup's a little bit funny, so I need to kind of trick it. If I can click it fast enough, it'll go. There we go. Now it's uploading. And the LEDs are still lit up because it's the same program that I was running before. There's also keyboard shortcuts. You can do Command U if you're on Mac, or look it up if you're on Windows. And here's the other thing. So if we go into our as Finder for Mac or Windows Explorer on Windows, if we go in here, then you'll find an Arduino folder inside of your Documents folder. And when you go in there, you'll see all these folders but no files. So what I was working on here was Create Text Simple LED. And you'll see here's the file here. This is a plain text file, but it's saved with a .ino ending. And that's just to signify that it is an Arduino sketch, but it's just text in there. But one trick here is if you do create a new file in the future, you want to make sure that you put the sketch inside of a folder that has the same name. So you can see this folder is Create Text Simple LED, and the sketch has the exact same format. It's just that it's a text file with a .ino ending. You will get an error if you don't do that, and it's just not going to run. So plan ahead maybe on that one. This was a pretty quick run through of the code, but it will get you started, and hopefully get you a feel for what can be done and what you want to do next. So good luck. Send me any questions. I can make more videos. I will make more videos. And I want to make videos about what you're interested in, so let me know. That was really long, and I don't know what we're going to do about it. All right. Okay, let's call it.